Welcome first-year students to this explainer. If you're just kicking off your journey into civil engineering, well, you're in exactly the right spot. Think of this as your ultimate roadmap for the next 4 years of study and really the rest of your career. We're going to dive straight into the absolute fundamentals every single civil engineer just has to know.
Here's what we're looking at today. We'll start with the welcome to the profession, jump into the 5 major disciplines, walk through the 6-step design process, look at the essential tools and skills you'll need, and wrap up with building a sustainable future. Let's get to it. Starting with Section 1, Welcome to the Profession, Building the World Around Us.
So let's just zoom out for a second. Civil engineering is literally one of the oldest, most critical engineering professions on the planet. As engineers, you're going to design, build, and maintain the infrastructure that we all rely on every single day. I'm talking buildings, roads, bridges, dams, airports, tunnels, water systems, the whole shebang. But the core objective? It all boils down to this: improving people's quality of life by providing safe, durable, and sustainable infrastructure. It's all about that human impact, right? Making lives better through the spaces people actually use.
Now, before you can start building those world-changing structures, you've got to survive something else first. Yep, those grueling first-year foundational courses. We're talking mathematics, physics, geology, and construction materials. Why are these so absolutely crucial? Well, because gravity really doesn't care about your design aesthetics. To be a great civil engineer, you need a rock-solid grasp of these subjects so you can calculate loads, analyze complex structures, and ultimately make safe design decisions. Without this groundwork, the rest just kind of falls apart. All right, moving on to Section 2, the 5 major disciplines, choosing your path. Civil engineering is a massive field, so let's break it down into its major branches. First up, we have structural engineering. This is where you figure out how to keep things standing safely. Structural engineers are the folks designing buildings and bridges to resist some incredibly intense forces. You're going to have to calculate for dead loads, which is literally just the weight of the concrete and steel itself, live loads, like a bridge packed with rush hour traffic, and extreme forces from things like high winds or massive earthquakes. Next, we've got geotechnical engineering. This one is all about mastering the ground right beneath our feet. You'll be studying soil and rock behavior. And why does that matter? Because you need to understand the Earth perfectly to safely design foundations, retaining walls, steep slopes, and tunnels. You know the Leaning Tower of Pisa? Yeah, that is exactly what happens when you don't consult a good geotechnical engineer. Every great structure has to start with what it's built on. Our third branch is transportation engineering. If you're passionate about keeping the modern world's arteries pumping safely and efficiently across cities and countries, this is totally your path. Transportation engineers focus on planning and designing vital networks, so think sweeping highways, crazy complex intersections, sprawling railways, massive airports, and intelligent traffic systems.
Fourth is environmental engineering. This is a supercritical branch dedicated entirely to the health of our planet and our communities. Here, your focus is on pollution control, waste management, water treatment, and overall environmental protection. You are literally the frontline defense, making sure that human development doesn't wreck the natural world, and on the flip side, making sure our environment remains safe for us to live in.
And finally, the 5th discipline, water resources engineering. This area is all about harnessing, controlling, and managing one of our most powerful natural resources, which is water. You'd be dealing with massive infrastructure like dams and canals, plus essential public safety systems like flood control, drainage, and the incredibly complex water supply networks that literally keep our bustling cities alive. Moving right along to Section 3, the 6-step design process, from idea to reality. Okay, take some notes here, because every single project you ever touch is going to follow this universal 6-step workflow. It always starts with step 1, identifying the exact problem, the requirements, and your absolute limitations. Then you head out into the field for step 2, data collection, surveying the site, testing the soil, all that good stuff. Step 3 is analysis, where you're crunching the numbers and evaluating different alternatives. That leads right into step 4, the actual design phase, drafting up detailed drawings and bills of quantities. Only then do you hit step 5, bringing in the heavy machinery for actual construction, executing everything to strict standards. But wait, you're not done when the ribbon is cut. Step 6 is the ongoing inspection and maintenance to guarantee that structure stays safe for decades to come. Let's look at Section 4, essential tools and skills, building your toolkit. To actually succeed out there, you're going to need a dual toolkit. On the technical side, obviously, you've got to master things like estimation, quantity surveying, and industry standard software like AutoCAD, Civil 3D, and Primavera. But here's the thing. textbook knowledge just isn't enough. You absolutely need those professional soft skills too. You could be a literal genius at calculus, but if you can't communicate with a demanding client, manage a chaotic team on site, or problem solve on the fly when an unexpected rainstorm floods your foundation, yeah, your project is just not getting off the ground.
And that brings us to our final section today, Section 5, Building a Sustainable Future, the Road Ahead.
Look, today, sustainability is completely non-negotiable. Your ultimate goal goes way beyond just pouring concrete and bending steel. You have to actively design projects that reduce environmental impact, dramatically conserve resources, and provide long-term, tangible benefits to society. As the next generation of engineers, this is the massive responsibility you'll carry into your careers. You aren't just building for today, you are quite literally building for generations to come.
Which brings us to the end of this explainer. Ultimately, civil engineering is about creating a better future for our communities through safe, efficient, and sustainable infrastructure. As you wrap this up and really dive into your incredibly challenging but totally rewarding coursework, just remember that you're learning how to construct the world around us. So, it leaves us with one pretty critical question to think about as you crack open those textbooks. What kind of future will you build?